Hello everyone and welcome to this new video. In the previous video we learned to repeat, but while is like a swift army knife. It serves for everything, but for specific tasks there are better tools. When you know exactly what you want to process and you know exactly how many elements there are, while it's over. When we have arrays, it is not necessary to define variables to validate the limit. It works, but you have to define variables and keep a counter. For its abstraction, you don't worry about how it iterates. You worry about what is done with each element. In traditional prompting, for highs the complexity of the counter. In symbolic prompting, it doesn't something similar. You tell the artificial intelligence, process this list, and it takes care of applying the rules to each element, one by one, without you having to manage an index manually. When you give an artificial intelligence a list of 10 tasks in a single paragraph, it is very likely to skip number 7 or mix number 3 with number 4. This happens due to the attention fragmentation. The for loop solves this by forcing the artificial intelligence to focus on one element at a time. It is like telling, take this list, grab the first object, do this to it, save it, and move on the next element. And that's how for syntax is defined. In this example, we have 3 elements that we need to read. We don't initialize variables. We don't worry about the numbers of elements. The artificial intelligence executes the blocks once for each element automatically. You don't need a manual counter. The artificial intelligence unrolls the loop. This means it is not going around like a traditional program, but rather it expands the code. If you have 3 elements, the artificial intelligence has if you had manually written the same instructions 3 times in a row, once for each element. There is no real iteration in the computational sense. There is a prompt expansion. It is like instead of saying, "What's the dish?" 10 times, you write a recipe that applies to each dish individually. The artificial intelligence understands them and separate tasks, not as a cycle. We can see the output is being generated correctly. In this exercise, we create an array and access its contents. For process, each element accumulates results in global variables and report progress, all in one single prompt. Warning: if your list is very large, more than 50 elements, you may approach the model's context limit. Symbolic for expand the instructions, and that consumes tokens. Use it with moderately sized lists. We see that the execution is taking place. We create an array where our order was updated. Process a two-dimensional matrix. Sometimes we need to read a 3 by 3 tables, a two-dimensional matrix. 4 inside 4. First, it goes through rows. Then numbers inside each row. We have the expected output. When you use each one, use for when you have a defined list, array, or collection. You want to process each element individually. The size of the collection is known. Example, apply discount to all products in the cart. Use while when you don't know how many iterations you need. You repeat on a condition that changes over time. You need to retry until something's happened. Example, Retry a payment until it is successful. Max 3 attempts. Golden rules. In while, always define a list or exit condition. In for, make sure the list is not too large for the context. We already know how to make decisions with if then else. We already know how to repeat process with while. We already know how to go through lists with for. But there is a type of flows control that is different. Direct jump. Sometimes when a condition is met, you don't want to repeat or decide. We want to go directly to another section on the prompt, like a logical teletransportation. In the next video, we will see go to the most primitive flow and the most dangerous. If you like this video, don't forget to give a like in the icon and subscribe to my channel. See you in the next video.